Hi everyone, today I will present my project, Customer Segmentation using Unsupervised Learning. So this project is a part of the Applied Artificial Intelligence and Data Science program by Great Learning in collaboration with MIT. And the goal of this project is to analyze marketing campaign customer data and identify meaningful customer segments using unsupervised learning. And the focus is not only on building clustering models, but also on translating the results into practical marketing strategies. Okay, so uh, before my presentation, I would like to say that due to time limitations, requirements by the organization, so I only select certain key points to present here. But you can find that in my final slide, there is a link to my GitHub repos that contains on the raw data as well as the codes and a lot of leading questions in my notebooks as well. So feel free to discover it. Thank you. Okay, so we begin with business problem. So here I would like to explain why one side face on marketing is inefficient. Okay, our main business problem is that customers are not homogeneous. They differ in income, family structure, product preferences, purchase channels, as well as their response to marketing campaigns. Okay, so if a company send the same offer to every customer, marketing budget may be wasted. So for example, a premium customer may respond to better exclusive offers, while a budget conscious family may respond better to a discount or value bundles. Okay. Another important point is that website visits alone do not guarantee higher customer value. Some customers browse frequently but spend very little. So the purpose of segmentation is to help the company move from generic marketing to more targeted and efficient marketing actions. So here I put some simple visualization of the idea. So consider that we have some kind of a customer segment like this. Uh, they have different needs. So you can see on the right hand side we have segmented marketing. So for each customer we need to provide and offer different programs so that to improve relevance, conversion, and efficiency of the marketing campaigns. Okay. So next one I would like to talk about the project objective. So the objective of this project is to identify meaningful customer groups using unsupervised machine learning. So I use customer information related to their demographics, household structure, product spending, purchase channel, and campaign response. So here is the workflows of my project. First, I would like to understand the customer as well as clean the data. In the second step, I would create some meaningful customer level features. That is feature engineering step. And on the next step, I would like to apply TSNE as well as PCA for dimensionality reduction so that we can reduce the complexity of the raw data. The next step is model deployments and selection. So here I would like to compare multiple clustering algorithms here. And finally, I select the most practical segmentation model. So the final goal is to translate the cluster into marketing recommendations that can support campaign targeting and customer strategy. Yeah. Okay. So let's have a look at our dataset. So basically, the dataset contains 2,240 customer records and 27 raw features. So I group them into 5 major groups. So the first one is demographics, including features such as birth year, education, marital status, income, household structure, product spending. Means they're spending on these kind of products, their purchase through the channels and as well as their response to the marketing campaigns. Okay. Um, so 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 I refer to my notebook here. So here is the data dictionary. So you can see the dataset contain a lot of raw features like this. Okay, here. So you feel free to discover it, and here is a glimpse of the dataset. Okay. So we have ID, year birth, education, and so on, and a lot of features like this. Okay. And here is some summary statistic for the data. I mean it's just the info, the overall info, not the summary statistic yet. Okay. Okay. Okay, and you can see that during my initial inspection, the only variable with missing value was income, and I will handle it during pre-processing stage. Okay. Okay, so the next step is to do EDA for the dataset. Actually, I do a lot of EDA here, so you can refer to my notebooks to see here. So first, I examine the summary statistic for numerical data as well as the categorical data here. I also do make to see to find the unique values as well as their frequency in these categorical data. Okay. I also do some initial reasoning to see if I can group some kind of marital status or education into one group to reduce the noise, because there are some groups with very low observations. Okay. So I refer here and propose my solution here. Okay. You can feel free to discover it. So for univariate analysis, I do first I try to analyze the distribution of income. So and as well as to see some outliers in the income, and I found out that basically while using the IQR method, I find there are 8 income outliers here. Okay, and these are the outliers. So if you have a look at the box plot, so you can see that there are extremely large outliers here. So maybe we need to consider to handle them as well as to handle some missing values mentioned before. Okay. Yes. Okay. So next I do bivariate analysis. The first one I would like to do the correlation heat map of key numerical variables here. I also do some scatter plot between income and other variables. Okay, so here's are the outputs, and okay, so I would like to talk about some of the key findings for this EDA. So first, income is strongly related to total spending and purchase activity. So in general, higher income customers tend to spend more and purchase more frequently. Second, catalog and store purchases are more strongly associated with high-value customers. This suggests that customers who buy through catalog or store channels tend to be more valuable for us. The third is that website visits are not always a good signal of customer value. Some customers visit the website often, but they spend very little. It means that website visits may represent browsing behavior rather than actual purchase intent. Okay. Next, I found that customers with more children tend to spend less. This may suggest that larger households are more budget conscious. Okay. So this finding help guide the feature engineering and clustering strategy. So instead of focusing on demographics, I need to focus on both customer value and purchase behavior. So the next step is feature engineering. So this is important because raw variables do not always directly represent customer behavior. So here are some raw features, and here as the engineer features, and my reasoning as well. So for example, begin with year birth, I create a year to represent customer life stay, and I combine all of the spending across all product categories to create total spending features, so I can get the overall customer spending value. And similarly, I sum purchase across web, catalog, store, and discount channels to get the total purchases feature. The meaning of this is the total buying activity across channels, okay, and so on. Here the engineer feature for this data, okay. Yeah, so you feel free to discover it. Quite a few figures here, but I think it's sufficient, yeah, to explore the data, okay. Yeah, yeah, so you can see here, and they are on part of the EDA processes. They provide a lot of information for me to do feature engineering, okay. Okay. By the way, I also do, so for the missing value of income, I do median imputation. So you can see that we have, see here that there was 24 missing values, but after median imputation, there was 0. Okay. So that's it. Okay. So for the next step, this before apply clustering, I separated the variables into two groups. The first one is the segmentation attributes. They are the variables used to build the clusters. They include income, spending, purchases, family size, customer tenure, web visit, recency, and campaign acceptance. The next one is profiling attributes. They are not, for me, they are not necessarily used to form the cluster, but they are used after clustering to explain the segments. So these include education, marital status, product spending categories, and campaign responses. Okay, and I also remove some irrelevant variables, including the customer IDs as well as the raw data fields. Okay, after that I do scaling for the numerical variables. It's important because clustering algorithms are distance based, and so large scale variables like income or spending can dominate the model if we do not scale them. And finally, I prepare the scale data for PCA and clustering. So this is the data preparation step. So for the next step, I do dimensionality reduction to reduce complexity of the data and to improve the performance of the models later. So so for the first one is TSNE. But TSNE is mainly used for visualization. So it helps me to show that how customers are distributed in 2 dimensions. So you can see here is that the TSNE plot shows some local groupings here. So you can see here, maybe here, and maybe here as well. But the groups, of course, the group were not perfectly separated, but I think it's normal in real customer data because customer behavior often overlaps. Okay. So PCA were used more of directly for modeling. Here is the cumulative explained variance by the PCs. So you can see that the first principle here, it capture the strongest customer pattern, like around almost 40%. Okay. And you can see that here is that the first 7 principal components explain more than 80% of the total variance, and the first 9 PCs explain more than 90%. So this means that PCA kept most of the important information while reducing complexity, And the clustering models were then applied to the PCA transform dataset. Okay, so refer to my notebook. You can see you can refer to my notebook to see more information from PCA here, more detailed information here. Yes, the numerical detail here for PCA, not only the graphs. Okay, here, and this is the visualization of data, a lot of detailed information for the PC. Okay, I also try to explain the drive as well as the components as well as the characteristic of each PC. Okay, so you can refer to this notebook. Okay, so the next step is to apply the models according to the templates and the suggestion by the organization. I do 5 unsupervised clustering models. So here are k-means, k-measures, here article clustering, DBS scan, and finally GMM. So each of these models deliver its unique advantages, and but for the final selection, it was the final model was chosen not only based on the statistics metrics but also in terms of business usefulness, because the final goal is to deploy the model in practice. Yeah, so so it must deliver business meaning as well. Okay, so for this step, because it's quite long, so I only refer to my notebook here. So you can see here. Sorry. Okay. So in my notebook, for each model I do, so you have k-means, k-measures, clustering, DBS scan, and GMM. So for each model, at the first stage, I will try to do some hyperparameter tunings. I think it's not comprehensive because I only select a range of the hyperparameters. So for example, for the k means I only choose k from 2 to 11. As long as I feel it is reasonable to choose that range, and then I will try to compare the model and select the k, the number of hyperparameters that make sense the most. Okay, and so and for example, for k-means, I also choose the model based on the CO score as well as using the elbow method. Okay, here I also discuss here, apply here, and visualize them here. Okay, so it makes sense to some extent, right? Okay, and also I also try to explain the meaning of each cluster proposed by the model. So you can see here, I try to explain in terms of business usefulness. Okay, so this is the output from k-means, and here is my reasoning whether they make sense in terms of business. Okay, so cluster 0 here, give them some name based on their characteristic, and the description of the cluster here. Okay, here, and this is the summary for the cluster. So I do the same thing for all of the cluster, for all of the models here. Okay, and here I just try to list out some key comparison to select the model. So for k means the highest CO score is k equal to. However, for me a two cluster solution was too broad for marketing. So it mainly separate customer into high value and low value groups. So I think it's not detailed enough for campaign strategy. So I choose 4 cluster solution. Although it has a lower CO score, but it produces more actionable and interpretable customer groups. And K-Meadows produced a similar insight, but did not improve significantly. Here, hierarchical clustering were useful for exploration, but the final solution it create one very smaller cluster like outlier, so making this solution less practical. DBS can it was not suitable because it grouped most customers into one large cluster and create severe imbalance. So it's not chosen as well. Finally, for GMM, it used the probabilistic approach. It produced balanced cluster, but it had lower CL performance and kind of complex to explain the results. So my final choice came in with 4 cluster because it was interpretable, balanced, simple, and marketing actionable. Okay, here. So here is the table to summarize the comparison. Okay. Okay, so after doing the modeling, I would like to discuss about in terms of business sense. So based on the K-mean for cluster solution, I give the cluster some name and describe their characteristic here. So quite detailed here based on the features. Okay. So for example, for budget conscious family customer, they tend to have larger family size, lower spending, higher web visits, and weaker campaign response. So they appear to be more price sensitive and deal oriented. The next one is premium high value customer. This is the most valuable group. They have highest income, highest spending, strongest campaign response, and strong catalog and store purchase behavior. So in terms of business, I think this group should be prioritized for retention as well as loyalty. Yeah, and we have another 2 segments here. Okay. So basically, I think this segmentation is useful because each customer group had a clear behavioral profile and can be linked to a different marketing strategy. Okay. So the next step for the next slide, I would like to talk about how to use the solution here to apply into business context. So first, we assign each customer a segment label, and maybe we can store it in our CRM or customer database. Okay. Then the marketing team can design segment-specific campaigns. So refer back to here. So for example, for this premium high value customer, maybe we can focus. Maybe our focus is on loyalty programs, premium offers, and exclusive campaigns for them. For this group, maybe our focus is to be cross-channel campaigns, offers in bundles, and some targeted promotions. For this group, maybe we offer them family bundles, value packs, and discounts. So, and finally, for this one, maybe the focus is on retargeting entry levels and website conversion strategies. I do actually. You can refer to. So maybe, okay. So as you can see here is that I also put them in my notebook. For the recommended strategy for these kind of customer segment, you can refer to my readme file or my executive summary report file. I also put it in the folder. So I also suggest some marketing strategy for them. Okay. And after implementation, the company should monitor KPIs such as the campaign response rate, the conversion rate, average order value, revenue per segment, and retention. And the models, and importantly, the model should be refreshed every quarterly or 2 quarterly. Like 3 to 6 months. So maybe because customer behavior changed due to the market conditions, or maybe directly due to our campaign as well. So that's it. Yeah. Okay, so basically that's the whole idea of my projects. So because this is an academic project, so there should be some limitations and a lot of future improvement here. So I just put it here because it's quite testing, so maybe just for this is a foundation for to explain the project in the future, as well as to deliver relevant project as well. Okay, so to conclude, I would like to say that my project show how unsupervised learning can turn customer data into practical marketing strategy. The key insight is that customer value is not only about website activity, it is more strongly connected to income, spending, purchase channel, family structure, and campaign responsiveness. So, and after comparing several modules, K-means with 4 clusters were selected as the final solution. And I hope that the final segmentation framework can help the business improve their campaign targeting, allocating resources more efficiently, and design more personalized customer strategy. Okay, thank you for your attention. So in the final slide here, I put the GitHub repos that include the raw data, the codes, the written up, very detailed of the discussion, as well as the figures. Okay, thank you for watching my videos.